Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics, specimen paper for the 2020 exam series, question 5. The continuous random variable x has probability density function f given, and the probability density function is given. Requirement A, find the probability that x is greater than 1. Requirement B, find the median value of x. I'm going to integrate from the low point of the range, which is 0, up to the point 1. The piece that this relates to is 6 over 5x. We'll integrate with respect to x. And now we'll see 6 over 5 times x squared over 2. This is the range 0 to 1. My values input give me 3 over 5. That's with an input of 1 into the x, minus 0, with an input of 0 into the x, which equals 3 over 5. Which equals the probability that x is less than 1. We want the probability that x is greater than 1. So in the calculation that I've set up, I'm working towards probability that x is less than 1. Now what I will do is I will show that probability that x is greater than 1 equals 1 minus the probability that x is less than 1. Here we have the probability that x is less than 1 of 3 over 5. Therefore, our result is 2 over 5. For B, find the median value of x. I'm going to set up integration from the low point to an unknown, which I'll call B, such that the result of the integration is 0.5, representing the median. I use the same integration from the part A, 6 over 5x squared divided by 2, from 0 to B, and I'll set this equal to, removing the equality on the left, I'll set this equal to 0.5. My inputs give me 3 over 5 times b squared minus 0 equals 0.5. b squared equals 0.5 times 5 over 3. b ends up as the square root of 30 over 6, which in decimal form is 0.913. We're done with A and B. Let's go on to part C. C, given that the expectation of x is 1, find the variance of x. The formula we'll be using is variance of x equals the expectation of x squared minus the expectation of x, and taking that expectation and squaring it. Note first, expectation of x means we want the integral of x times the function that we're working with. So in this case, we're working with the expectation of x squared, which means the integral of x squared, and our limits are 0 to 1. Multiplying x squared by the function 6 over 5x with respect to x, which is the first piece, and the second piece from 1 to infinity of x squared times 6 over 5 times x to the power of negative 4. Integrating, I end up with 6 over 5 times, I have x squared times x, which is x cubed. That will become x to the power of 4. and I will divide by 4, or I can multiply by 1 over 4 on an interval of 0 to 1. And for the second piece, we end up with 6 over 5 times the x squared times x to the power of negative 4 results in x to the power of negative 2. Integrating, we get x to the power of negative 1, and we'll multiply by 1 over negative 1. My limits here will be from 1 to c. I'm going to replace the infinity with c, working with the idea of a limit, that c represents the idea of an input that we will evaluate as c approaches infinity. Simplifying with inputs, for the first integration we end up with 6 over 20 times 1, that's based on the input of 1, minus 0, which is the result of the input of 0. For the second integral, I have plus 6 over 5 times c to the power of 1, or 5c, times, actually I'll just make that negative, plus negative 6 over 5c, minus the second term, which simplifies to negative 6 over 5. Now I'm going to note that as c approaches infinity, the value of negative 6 over 5c approaches 0. Now continuing with my simplification, I have 6 over 20 times 1 is 3 over 10 minus 0, which is out. Now I'm going to go ahead and write in plus 0, referencing this 0 that I've identified as the result of c approaching infinity. Minus negative 6 over 5 is plus 6 over 5. And we simplify to 3 over 2. Now the 3 over 2 is the expectation of x squared. Going back to variance, variance of x equals our result of 3 over 2 minus, now what we have is the square of the expectation of x. Given, note in C, given that the expectation of x is 1, so I'll fill that in with 1, I have 3 over 2 minus 1 squared, which is 1/2. That completes part C. Let's now go on to part D. Part D, find the expectation of the square root of x. So my setup is going to be that this will equate to the integral first from 0 to 1 of not x times the function, but square root of x times the function being 6 over 5 x with respect to x. And again, we have a second piece from 1 to infinity, which will be the square root of x times that second piece, 6 over 5 times x to the power of negative 4. Integrating, on the left I have square root of x times x, which is x to the power of 3 over 2. Integrating will end up with x to the power of 5 over 2. We have a multiplier of 6 over 5 to begin with, and we now want to divide by 5 over 2, which is our new exponent, or we can multiply by 2 over 5. And this is from 0 to 1. Adding our second integral, we have the square root of x and x to the power of negative 4, which combine to x to the power of negative 7/2. Integrating will get to x to the power of negative 5 over 2. Previously multiplying by 6 over 5, and now dividing by the new exponent of negative 5 over 2, or multiplying by 2 over negative 5. Here our interval is from 1 to infinity, I'm going to change that to 1 to c as described earlier, and I'll note that as c approaches infinity, the value 6 over 5 times 2 over negative 5 times x to the power of 5 over 2 in the denominator approaches 0. Now simplifying with our inputs, x to the power of 5 halves with a value of 1 will be 1 times 6 times 2 is 12 over 5 times 5 is 25, minus the value resulting with an x of 0 is 0. And for the second expression, our inputs, we've already indicated that the input of a c results in a value of 0. The input of 1 will give us x to the power of negative 5 over 2 is 1 over 1, which is 1, times 6 times 2 is 12 over 5 times negative 5 is negative 25. And we have 12 over 25 minus negative 12 over 25, which is 24 over 25. This completes the requirements for Part D, and this completes the requirements for question 5.